Hello, everyone. Welcome to the session. I'll let the last few scragglers get in. My name is Paul Vick. I'm the technical lead for the Visual Basic compiler and language. And today we're going to talk about some of the features that we've been working on, some of the ideas we've been working on for the version of Visual Basic beyond Visual Basic 2005, the one that's about to come out. So now we've got some exciting ideas coming up, and they really cover three major areas. Three areas that are really going to address productivity gains for the Visual Basic developer. Now the first one you probably already are a little familiar with. It's Language Integrated Query, or the LINQ project. You've seen it in the keynotes probably and may have gone to some of the other sessions. But for the Visual Basic user, it's really going to give two main benefits. First, it's going to provide a way to query data that is stored in .NET objects. So now all of us work with objects all the time, but anytime we want to query them, anytime we want to filter them, anytime we want to project them, anytime we want to sort them, we end up having to write the same code over and over and over again. It's the same plumbing code. Really code that the Visual Basic compiler, the Visual Basic language should be handling for you. And Language Integrated Query will provide that for you. The other thing it will provide, of course, is as Visual Basic programmers, we tend to work with a lot of external data. We write a lot of SQL code. We get a lot of XML from the web. We produce XML. And anytime we want to query that data, we have to step outside the Visual Basic language. We have to go to something like SQL, and we have to write queries that are not integrated well with the environment that you're working in. So what Language Integrated Query will provide for us then as Visual Basic developers is the ability to learn one language, Visual Basic, and then be able to work with SQL data and XML data, query it, manipulate it, without having to step outside the tool that you already know and the language you already know. Like I said, you probably heard about this before in some of the other talks. But there are two other things that we've been working on, things that go beyond what you've probably heard about with Language Integrated Query so far. So the first thing is we're working on ways to be more productive with what we're calling dynamic data. Now, it's great in sort of the theoretical environment. Did you make the announcement? Okay. We have an overflow room 410, so if you don't have seating space or can't find a space, you can move to 410 and they'll be broadcasting it there. So what we're working with is dynamic data. Now, what is dynamic data? Now, in the theoretical world, when we give these presentations, we have class definitions, we have schemas, everything is nice and tidy. But out there in the real world, of course, we all know that data is not always particularly well typed. Database tables change, columns are added, columns are removed, data types change. If you get XML data, maybe you get an XSD, maybe you don't, probably you don't. And even the same XML data from two different sources is going to be subtly different. Now, to deal with this kind of dynamic nature of data, the fact that the shape may be different than what you were doing, than what you thought at the time that you built your program, what we do as developers is we write a lot of extra code to handle this situation. But again, this is the kind of plumbing that the Visual Basic language and compiler could handle for you. And so we've been looking at ways to make working with dynamic data much simpler. And then the final thing we've been looking at is the growing importance of XML. A lot of us have to produce XML as a daily part of our jobs. We have to consume it, and then we have to produce it to hand it back out to the web, to other services on our network. And the LINQ project introduces XLINQ, which is a class library which is designed to make working with XML easy, but it's still an API set. You're still writing code to instantiate objects, call methods, those sorts of things. So what we're looking at doing is integrating XML as a first-class concept into the Visual Basic language. So you don't have to remember which objects to instantiate. Do I want an X element here or an X attribute there? Anything like that. Instead, you write XML just as you would in a text editor, just as an XML editor. and the compiler takes care of building the appropriate objects for you. So this is what we're going to cover today. And I'd like to jump in a little bit with a demo of language integrated query. Now, I'm a bit of a lazy person, so when I pick demo subject, rather than inventing something new like customers and orders and that sort of thing, I actually picked something that is relevant to me, something that I can use in my day-to-day life that has nothing to do with work. Now, as some of you may be familiar, I actually write a weblog. It's called Panopticon Central. And here I'll display it up on the screen here. So now this weblog is hosted by my web service provider, and they're really a great service. They provide me with some web tools that allow me to analyze the traffic, tell me who's been hitting which pages, all that sort of thing. But the problem is, of course, that those tools are static. They have the queries that only they thought were interesting. And if I want to run some of my own queries on the data about who's hitting which pages and what time of day and that sort of thing, I'm really kind of out of luck. Now, the great thing is my web service provider allows me to look at my server logs. So now what I want to do then is I want to work in Visual Basic and write a little tool to analyze the server log for my web log so that I can figure out what's going on with it. Now, today, without the work that we've been doing, I'd have to push it into a SQL database, or I'd have to use some other random tool to do it. There are plenty of tools out there that do it, but I really want to work in Visual Basic because that's what I know. So let's flip over the demo. So now I've already started my application a little bit. I've written a little skeleton console application here. And what this console application is going to do is it's going to take a log file, and I'll just open, I have this example log file. It's just a bunch of text, a bunch of lines of text that tell me about hits to my weblog. And what I've done is I built this simple little object called a log file that just parses that text and builds CLR objects, just regular objects. Very small bit of code at this point. And then I've written this analyze method that I'm going to use to analyze the data, analyze those objects that I've loaded. So now right now, there's nothing in my analysis method. I haven't done any work yet. But here we can see my log, browse my log file. Browse is just a simple little tool, simple little function that I've written that's going to instantiate a data grid and use object binding to display the results of that log file. This is all technology that exists in Visual Basic 2005. So we can run this. And it's thinking. And here we see this form, the grid, with all the data from that log file. Now the first thing I'd like to do is, this has about 15 or 16 different columns. What I'd like to do is just get that down to the one column I care about right now. And that one column is what page was hit. So what I'm going to do is I'm just going to write a little simple query. So I'm going to select the request URI stem, which is the fancy name for the page being hit, from each row in my log file. And now I'm going to browse that. And here we see now I have just the pages that are being hit. Now you notice that there are a lot of duplicates here. So I just want to see just the unique pages that are being hit. So I'm just going to add a distinct here. And we'll see, okay, now I've got all the distinct pages. Now, just for fun, I'm going to sort these so that I can see them a little better. So let me break this here. Order by request URI stem. And now I've got a sorted list of just the distinct pages that have been hit. Now, of course, normally, if I had been writing this without language integrated query, this would have been another 20, 30, 40 lines. I would still be typing as I was standing here in front of you. So this shows just a little bit of the power. But now what I really want is not just the pages, but I'd like to know the amount of bandwidth that on that particular day, each page consumed that was hit. So now, if I had a full working version of VB 9.0, I could just use my little old grouping and aggregation trick from SQL. But unfortunately, we're working with a prototype here. It's not fully functional. We're not ready to ship yet. So instead of using grouping and aggregation, I'm just going to use a couple of other features that kind of show off the power of this. So what I'm going to do is I'm actually going to write a function called page hits, and it's going to take a page name, and what it's going to return is a list of the hits to that page. So the way I'm going to do that is I'm just going to say return a query, select the request bytes and the response bytes. From the rows in my log file, where the request URI stem is the page that I wanted. So what I've written here is a query that's parameterized by a parameter of a function. Now, you'll have to avert your eyes for a moment because as prototype code, it's not completely working, and I have to do one little hack. So just sort of close your eyes, go to a happy place for a moment while I do this. You would not have to do this in real life just to get this working. All right, so now my query is working. Just ignore that. So now what I'm going to do is I'm going to take the result of that function and I'm going to integrate it with the result of this other query that I wrote to get the page names. So what I'm going to do is get the list of bytes, and what it will be is I'll select the page and then the hits for that page, which I'm going to get by calling the page hits function with the page name. And so we're going to get that from each page in the results of the pages query. Now what I've done here is I've not only called a function that returned the results of another query, but I've aggregated several queries together. Now the great thing about this is because the query, language integrated query, is a deferred execution, what this means then is that I get very low cost for running this query. It's not as if the pages query gets run, and then the page hits query gets run, and then the bytes gets run, and all this has to be stored somewhere. No. It's not until I actually browse the results of this query that the query starts to fetch results. And only as I ask for each row will the work be done. So now we can look at the results of the query here. Now, what we'll see here is, the hits column is actually empty, which is kind of odd. Now, I don't actually have a bug in my query. If you go back and look, what I did was I selected the results of a query. Now, what this does then is this returned a collection of hits. So what I actually have here is a hierarchical result set. Now, as you notice, what we've really used here, the metaphor we've really used here is SQL. These queries look very, very similar to SQL. And that's very conscious, because most VB developers have to deal with SQL all the time. It's a very familiar language to them. And we want to leverage that knowledge into language integrated query. So you can take the concepts you already know and understand and put them into Visual Basic. But this shows that it's not exactly SQL. SQL can't handle hierarchical result sets. It can't handle a column that contains a set of values instead of a single value. So we've extended this language to deal with even more exciting things like hierarchical results, and it makes it easier to work with objects and with XML. So what I'm going to do here is I'm just going to use a little aggregate function, sum. So I'm going to sum up all the values in that result for each row. And now we'll run it. And we'll see that now we have the aggregate results for each page. Now, actually, I'm going to, oh, wait, one more, and then you can applaud here. And then I'm going to, just for fun, I'm going to order by the hits, and I'm going to sort descending so I can see what the most popular page for that day is. And here we'll see that day, well, what a surprise, my RSS feed was the most popular. But then there was an article here about sort of talking about the differences between program managers and developers at Microsoft that day, and that was pretty popular. So now I've got the results that I was looking for with just a few lines of Visual Basic code. I didn't have to go into SQL. I didn't have to run any extra tools. I just used knowledge that I already had and Visual Basic. Now you can applaud. Pretty cool, huh? All right, so how many people here actually have gone to the link overview session that Anders Halsberg presented? Probably most of you. Okay. I'm not going to go too much into detail about how the basics, how language integrated query works under the covers, but I do want to cover it just a little bit because it is worth talking about. So the link projects, what the link project does is it defines a set of API patterns that define basic query operations such as projection, filtering, sorting, joining, that sort of thing. And on top of those standard API definitions, then, the languages such as VB and C# and any other language that wants to can implement language support. Now, it's interesting to note that each language can choose to support it in its own way. Visual Basic has chosen a very SQL-like syntax. C# is not as close to SQL. Other languages could choose radically different syntaxes if they like. And underneath those APIs, then, are implemented three standard sets of query providers. One for objects, D-Link for SQL databases, and X-Link for XML. But the interesting thing about it is that these are just individual implementations of the APIs. They cover probably the 95% case of data in the world. But if there are other data providers that want to make themselves query-enabled, they can be. And because the Visual Basic language support is built on top of just the APIs, we will automatically work with those providers. There is no engine that the Visual Basic language is tied to. There's no specific providers. We'll work with any query-enabled component that anyone wishes to produce. And this is incredibly powerful because even though we're going to hit the 95% case when we ship, there are going to be other cases, and we will support them right out of the box. So the feature, what we're calling queries in Visual Basic, are query comprehensions. And this is the sort of the summary of what are the basic operations that we're going to support in our query language. And for those of you who know SQL, which is probably most of you, this is going to look like a very familiar list. We support select, where, any and all tests, joins, left, right, outer, inner joins, full outer joins, grouping and aggregation, things like top, union, intersection, and sorting, of course. So we're really going to provide you the full range of query capabilities in the language itself. Now, you may be wondering why we call this query comprehensions. Why such a fancy name? And the reason is really because what we do is we take a very high-level syntax, and here you'll see an example query from the demo I just did. And what we do then is we take that and we turn it into a set of lower-level API calls. This is sort of the full expanded form of what this code will generate. You write this. The compiler generates this on your behalf. And I just want to walk through it just for a minute to give you kind of an idea of how this works. So we have here the data source. And that becomes the input to a call to one of the standard query APIs. So we start with the where clause. That turns into a call to sequence.where, which is the where provider for regular objects. So what you'll see here then is passing into the where, we pass the data source, and we also pass the address of a delegate to a method that contains the filter condition. So we take the filter condition from up here, and we move it down into a function that then will be applied when the query is run to determine whether a row will be included in the data set or not. Similarly, the select clause is turned into a call to sequence.select, which is the select provider for objects. Now, what a select does is it takes one type, say a log row, and produces another type, an integer. So what we do is we take your select expression, we pull it out into a function that takes a log row and returns an integer, and then we pass the address of that to the sequence.select method. Then as the query is executed, that delegate is applied to the results of the filter and produces the integer result for that row. So this is just sort of a quick overview of sort of what happens underneath the covers. Now the great thing about it is you don't need to know any of this. This is interesting, but you don't really need to know. You can just write the query and it'll work. But it's good to know sort of what's happening underneath the covers. So now let's take a little more of an advanced case. I showed you some of the basic query operations. And here again is an example query from the demo that I was doing. Now, I just did select page and the hits, but let's say instead I have this class called hitInfo. It's a class that I'm going to pass off to some other component that I'm going to save or something like that. And let's say that as a result of this query, I want to produce a sequence of hitInfo objects. Now, of course, I'm in a little bit of a problem because if you look at it, hitInfo doesn't have a nice constructor that takes all the things. It just has these fields. I can't put anything in that select expression right there because there's no single expression that will allow me to create an object and then initialize its fields at the same time. So what we've done is we've added a feature called object initializers. And what they do are exactly what I just said. They allow you to create a hitInfo object, and then afterwards in brackets, you can just list out the field initializations that you wish to make. So in a single expression, you can create an object and initialize it at the same time. Now this is incredibly powerful for queries. This is absolutely essential. But it's also really useful for us as Visual Basic programmers. Because there are lots of times when we do things like this. I'm creating a new hitInfo object, and I just need to initialize it outside the context of a query. Now, the interesting thing is that this is really just a rewriting of code that today we write all the time. Really, it's just this. I create a new hitInfo, and then with it, I just initialize the fields. I mean, how many of us have written this code over and over and over again? So now we can do this in just one simple step, one simple expression. It's very natural. We'll take questions at the end. So now, along with object initializers, we're also working on collection initializers. Now, this is code that works today in Visual Basic 2005. I'm initializing an array of integers with a set of values 1, 2, 3, 4. Now, the unfortunate thing, of course, is that if I wanted to initialize a list of integers, a generic list, I can't use this syntax today. So what we've done is extended the language to allow that. Basically, just like array initialization, any object that implements the iList interface, which is an interface that allows for adding new elements to a collection, any object that implements the iList interface can now be used in the same syntax, initialization syntax, that you're used to with arrays. So this is incredibly powerful for working with things that are not just arrays. So now I'm going to take a step back and go back to the example I was using. Before I was talking about object initializers. And you'll see here, I did a select page and hits, and I didn't really say what I was doing at the time. I just kind of did it and went on. And you'll notice that the browser was able to reflect on that and to see the field called page and a field called hits. But really the question is, sort of what's going on here? What is the result type of this query? I didn't state a type anywhere in here. So what I used here was a feature we're calling anonymous types. And what anonymous types do is they are essentially an object initializer, just like I showed you a couple of slides ago. However, there's one crucial difference. There's no type I gave there. I didn't say new hit info. I just said new, and then I gave an initializer. Now, what happens when you do this is that the compiler will produce an anonymous type. I made up a name here, but really it's a name you can't say in the language. It produces a type, and then it creates that for you. Now, again, this is something that is very, very necessary for queries because we're doing projections all the time, and to have to create a new class every time I project would, of course, be completely terrible. But it's also something very useful day to day. I don't know about you, but in all the Visual Basic code I write, I'm always creating little types, little structures, little classes, just to hold little bits of information, just so I can pass them around, just so I can store them. And what this allows me to do then is just create storage like that on the fly without having to go declare a new type and create fields. And now with Object Initializer, I don't even have to create a constructor. So it makes working with data inside your application much more natural. It flows much better. Oh, yeah, that's an anonymous type. I forgot I had that. And just with collections, just as with anonymous types, we also have anonymous collections, or anonymous arrays, actually, just arrays. So now if we go back to this example that works in Visual Basic, here I had to create a new variable, values, to hold the array that I created, 1, 2, 3, 4. Now, wouldn't it be much more useful if I could just use that initializer as if it was an array? I mean, frankly, why do I have to create a variable? Why do I have to create a name? So indeed, we're extending the language to allow you to do that. I can just say for each v in curly brace 1, 2, 3, 4. Now I don't have to create some random storage for it if I don't need it. I can just state the array as it is. And again, this is something that's very useful in general life and in queries. Like, for example, if I wanted to write a query, oh, I skipped a point here, so let me go back and say it. The other thing that's important about this is that because I didn't state the type of the array, we'll infer the type of the array for you. Here they're all integers. So we say, oh, well, obviously you want an integer array. In most cases, arrays are very homogeneous, and the type inferencing will work very well. In the worst case, it will fall back to an array of objects. It'll be very obvious, and you can put a type there if you need it. So let's move on to an example query. I was saying, let's say I wanted to write a query that took all of the rows in my log file where the method that was being, the HTTP method that was using was either get or head. Now again, I could create a temporary array. I could put that array then, and I could use to say where the request method is in that array. But here I can just state it directly. I don't have to go create some random variable and remember what the name is. I can just say where the request method is in this list, get and head. Very simple. So I'll do questions at the end. So the final piece of this puzzle is local type inferencing. Now, if you'll notice again, this query I wrote that created the anonymous type. Now, normally, as you know, in VB 2005 today, if I wrote something like this would be object. And in fact, if I had option strict on, I'd get an error saying you can't declare a variable without saying a type. But what we're doing now is we're doing a very simple form of type inferencing. You're initializing bytes with a select statement here. We know the type of the select statement. It's pretty obvious what you intend the type of that variable to be. So what we will do is pretend as if you had said, now of course since it's an anonymous type, you couldn't even say the name, so this is why it's absolutely necessary for queries. but we will fill in the type for you under the covers. So you write this, and this is what we'll see, what the compiler will generate. And as with all the things I've talked about, this is usable outside of queries. So like today, all of these declarations would be considered object, and you would get an error with option strict on. But now, all the types can be inferred. X will be of type integer. Y will be of type string. Z will be of type double. Now, there will be a compiler option to allow you to turn this behavior off. Obviously, for compatibility reasons, you have to be able to turn local type inferencing off. But this will probably be the default for Visual Basic 9 because it makes it so much more useful. You can simply omit the type, and you will still get strongly typed behavior. All right, so this is all stuff that you probably, if you've been to any of the other LINQ talks, you've seen maybe the C# version of it, or you've seen some of this discussed. So now I want to talk about a few new things, a few things that you probably haven't seen. Now, the first thing is, as I talked about earlier, one of the things we've been thinking a lot about is dynamic data, data whose shape changes a lot. Now, I want to switch back to my little application that I was working on. Now, in addition to being somewhat lazy, I'm also a little bit vain. I have to admit it. It's terrible. And what I'd really like is to include not only in this query how much bandwidth each page is using, but I'd also like to know how many people are linking to my weblog. I'd like to know when people are talking about me. So now the great thing is there are a couple of websites that track weblogs. One of them is called Technorati. And the great thing about Technorati is that what you can do is you can send it a query, an HTTP request, and it will give you back an XML document that tells you about links that have been made to your weblog recently. So now here I can show you, they call it a link cosmos. Kind of a fancy word, but I don't know why. So here we see the sample result of a query that I've run. We can see a little bit of information here about my weblog, Panopticon Central. And then down here are a collection of item elements that contains information about links being made to my weblog. So now what I'd like to do is I'd like to integrate this information into my query. And the thing about it is, so far as I know, and maybe I just couldn't find it, there really is no XSD for this. There's a web page that describes what should be there. Things may change, but there's no real structure. There's no real absolute structure for this. So now what I'm going to use first is I'm going to use the Xlink APIs to load the results of one of these queries into an XML document, an X document object. So let's start with that. So we'll get the Cosmos for my weblog as X document. Get current link Cosmos. And now what I'm going to do is I'm going to use the language integrated query to get out the list of people who are linking to my weblog and what pages they're linking to. So just as I wrote a query over objects, I'll write now a query over XML. So here we go. I'm going to get links, and I'm going to select the source link, which is going to be from an item in the XML document, the sub-element weblog, and then the sub-element URL. And here, let me wrap this so that everyone can actually see this. And then I'm also going to select out the destination, which is going to be the link URL element. And what I'm going to do then is select this from the item, every item in the cosmos whose descendant obviously spelling is not my strong point. Link. Oops, item. All right. So what I'm using here are standard Xlink APIs to get at sub-elements of this document, descendants of this document. Now, the thing of it is, if you look at this, what I'm just doing here, all I'm doing here is late binding. Now, if you remember in Visual Basic, late binding is when I just type something as object, and then I call a method on it. And you don't get any type checking, and at runtime, whatever object it is, we try and call the method on it. If it doesn't exist, you get an exception. But you essentially defer the binding of the names until runtime. So now that's all I'm really doing here. I'm stating at runtime, this element, this item thing, is going to have a sub-element called weblog. And that sub-element is going to have another sub-element called URL. But I have to call all of these APIs to do the late binding. What I'd really like to do is treat it just like late binding in Visual Basic, where I don't have to say object.get method of some sort of thing and then execute. No, I just say object dot, the power of the dot. So what I'm going to do actually is I'm going to simplify this query, and I'm going to remove all this junk, and I'm just going to say item.weblog.url, and I'm going to say item.linkURL. Now, because this is late binding, I'm going to need to cast it. I'm going to need to tell the compiler what type this element is because, like I said, I'm deferring the binding of this until runtime. So at compile time, the compiler doesn't know what type link URL is. Similarly, I'm going to late bind descendants. Now, descendants is not a normal operation in Visual Basic today. When I say x.y, y is a member of x, an immediate member of x. It's not some descendant. It's not the XML concept of descendant, which is really the same as saying x descendant y is saying, find me all the y's in anything that I contain, even further down into the hierarchy. So what we've done is introduce a new set of qualifiers that allow you to access these XML concepts. So instead of saying cosmos.item, I say cosmos.item. And what this means is, in Cosmos, comments from the peanut gallery here, it says, for this XML document, anything inside it, anything sub-element that's named item, give that to me. Because I know there's some down here. I mean, if we go back to, just for a second, looking at the actual document I'm reading, what you'll see here is that there's all this other junk at the top. And so I really don't want to have to dot through everything. I just know that there are those items down there. Now, again, because we're working with prototype code, I'm going to have to ask you to avert your eyes for just a second while I stick in something to make this query actually work. All right, it's over. That wasn't too painful. So now what we can see is that I've taken this XML document, and now I have a list. I've run a query, and I've got a list of links to my weblog and then the files that and the pages that they're linking to. So that's pretty cool. It is pretty cool. But I'm not satisfied. There's one more thing I want to do. I want to integrate this with the previous query. So what I'm going to do is I'm going to take this query, I'm going to delete it here, and I'm going to go up and do exactly the same thing I did with the hits. I'm going to create me a function which is page links and takes the page name and returns a list of the pages that link to it. So now to do this, I'm just going to modify my query just slightly. So I'm going to select the person who's linking to me from the items in the Cosmos. And then I'm going to filter where the URL that is being linked to on my weblog is the same thing as the page I'm looking for. And just to save myself the trouble, I'm going to go ahead and do the same ugly hack. All right. So now again, I have this second parameterized query that parameterizes a query over XML. Now I'm going to then include that results back down here in my original query. So now I'm just going to rename it results to be a little more accurate. So we got page name, we've got the hits, and now I'm going to include the number of people linking to that page. And so I'm just going to use the count of the links to that page. So now what I'm doing here is I'm aggregating not just two queries over objects, but I'm aggregating queries over XML and objects together. And I'm doing it in a way that's extremely natural, where I'm just using the dot syntax. I'm not calling elements or descendants or that sort of thing. So now let's take a look at the result. Oh, dear. Wow. Oh, you're right, I did. Thank you very much. I always forget that when I try this out. All right. Now let's see the results. There we go. So now we can see that, yeah, hey, part of the reason why this web page is so darn popular is because a lot of people are linking to it that day. So this is a great example of how we can use late binding to work with XML and then query over it and aggregate the results together and produce something very, very easily. Yeah, now you can applaud. I got no more for that. All right, so let's talk for just a minute about how this works. So I showed you late binding over elements on XML and over descendants, but we actually cover all of the XML axes. So here I just have a little example piece of code that accesses the descendants and the element, which I just saw, but also attributes, XML attributes. And we actually have syntax for all of these. So you saw the dot syntax, you saw the dot, dot, dot syntax. We're also adding a dot at syntax for accessing attributes. Now for the moment, all of this syntax applies only to XML. That's where we started. But if you think about it, you'll realize that there are a lot of objects out there in the world that have dynamic members just like XML. For example, even within the Microsoft set of objects, you can think of sort of like data sets, for example. They have dynamic members. Columns can be added and removed. And there are plenty of objects in the world that are like this. And so what we're looking at doing is actually extending this support past XML in a standard way, have a standard way for objects that have dynamic members to expose them, and then automatically get this dot syntax so that you don't have to figure out which APIs to access dynamic members through. You can just say object dot and it will work. Yes, attributes, descendants, and elements. Now, there's one thing I can't show you today because it's still sort of in the process of being built, but I did want to talk about it because I think it's very important. And that is the concept of dynamic interfaces. Now, if we go back and we look at this sample code I was just showing, you'll notice two things about it. First, as I showed you in my demo, I have to cast things because the compiler doesn't know what the result of this late bound access is going to be. I know that cosmos.at version, the attribute version, is going to be a double value. I know that the link created date is going to be a date. But the compiler has no way of knowing this. And even worse, I'm not going to get IntelliSense because this is late binding. When I say item dot, because it's late bound, the compiler doesn't know, oh, there's going to be this link created sub-item. So it's not going to show me anything. Now, if I happen to know it's there, that's great. I don't have to worry too much about that. And in a lot of cases, you'll know what the structure is. But what if you don't? What if you want a little more help? You want to type less you want less casts, and you want more IntelliSense. What we're doing is we're working on the concept of a dynamic interface. Now, what a dynamic interface is, it's like a regular interface, except it can be imposed on any object as a late-bound call. So now what you see here, then, is I've created a dynamic interface that represents the late-bound item object. And I say any object that I cast to this dynamic interface is going to have a created property, and it's going to be of type date. Similarly, I've created a dynamic interface called Cosmos. And anytime I cast an object to this dynamic interface, I promise that it's going to have a property, an attribute property called version, whose type is double. And it's going to have a descendants property called item. Actually, I apologize, the slide. It's going to be of type item, not integer. I think I had some IntelliSense problems there. So now what this allows me to do then is if we go back to the original code, this is going to define the late-bound shape of this code that I just have at the top. So I can rewrite it now. And I can say, you know what? The root of this XML document is this dynamic interface Cosmos. And that tells the compiler, here are some things to know about the late-bound shape of this object. So now when I say Cosmos dot, I see version. I see item. Similarly, if I access an item, I can give it a shape as well. And I know that this item has a property called created. Called link created, actually. I apologize. So what we're going to see then is I don't actually have to cast now. I get IntelliSense. I get strongly typed behaviors, even though this object is still late bound. Now, for example, if I got an XML document and I cast it to Cosmos, and it was not a link Cosmos, and it had no sub-items, and those sub-items did not have a created field, then what would happen is I would get the same late-bound behavior that I get today. I would get an exception. So it's not a panacea, but it allows you to work with data whose shape may change, or may be dynamic, or where you don't have the full shape of it available. So now I want to show the last piece of this puzzle. Now if we go back to this demo, now this, showing it in a little grid, this is great. Don't get me wrong, it's wonderful. But what I'd really like to do is I'd like to run this on a regular basis and produce reports. I'd like to produce reports that then I can look at and play with. And this grid, I could add a lot of functionality to this grid to make that happen. But let's be honest, there's already an application out there that takes data, puts it in a grid, and allows me to play with it. And that application is Excel. So what I'd really like to do is generate a little Excel report from this query. Now, one way to do that is I could use automation. I could go to maybe use VSTO, Visual Studio Tools for Office. I could automate Excel and build the spreadsheet, but that's just going to be a lot of code. The great thing is now Excel supports an XML format. So what I've done is, if I can switch over here, what I've done actually is I've created this example spreadsheet. This is kind of what I want my report to look like. I went in, I just created it, I filled in some test data, that kind of thing to get an idea. You'll have to excuse my lack of graphic designer expertise. I'm obviously a programmer. But anyway, this is good enough for my purposes. So now what I'd like to do is generate this report, but I'd like to fill in where this sample data is. I'd like to fill in the results of that query that I just ran. So I'm going to be really lazy, and what I'm going to do, we'll switch back over here. What I did was I saved that example file out as an XML format. So here is the lovely Excel XML format, full of lots of interesting and exciting things. And what I'm going to do is I'm not even going to worry about what's in it. I'm just going to copy it. And here I'm just going to create a little bit of space, and I'm going to say, you know what, this is going to be the body of my report. So I'm going to put the body here, and I'm going to paste it in. And hey, I didn't get a bunch of errors. Why didn't I get a bunch of errors? Because now Visual Basic natively understands XML literals. So yeah, that is pretty awesome, isn't it? And in fact, if we take a look here, I'll just comment this out. Console that right line body. Console that read line, so it doesn't all go away. We take a look at it, we see what I've got here is just a bunch of XML. And it's in an object form that I can work with. So now, this is still just the example data, though. I need to get my query into that. So now if we go up here in the middle of this and look, you can see where my sample data is. It has a particular format. It has a bunch of row. It has a row element, and then it has a cell sub-element. Then it has a data sub-element. So what I'm going to do is I'm just going to write a query that produces a set of these XML literals that look like this. Now, I'm not going to make you sit here and watch me type it, so I've actually got a little bit of sample code. So we take the rows, and we're going to select, and I'm going to just take a real quick bit of text here. So now you'll see here I just copied and pasted a bit of sample data. I'm going to select this from the results of my previous query. So R in results. So now what I want to do is I want to fill in the data from that result, the previous result query, fill it into this XML literal. And so what I can do here is I can replace Bob here with Page. Now, I hear some laughing over here. I think any of you who are familiar with ASP.NET should be familiar with this sort of syntax. ASP, yes. Basically, the % equals is a hole in the XML that you can use to put in any expression, any VB expression, into the XML literal. So here I'm going to put the page name. Oops, not a page. I'm going to put in the hits. And I'm going to put in the links. So now the result of this query is a list of XML elements. And we can kind of see, well, let's print it out here. Actually, if we print this out, what you're going to see is a bunch of ugly columns, but all right. But it's a bunch of row objects here. So now what I'm going to do is I'm just going to use the same thing I just did, the whole XML holes. I'm going to go to the body of this report. I'm going to get rid of this sample data. I'm going to make another hole here, and I'm just going to put in the result of my query. And what happens is, because this is a list of X elements, the compiler knows to just generate those as a part of the XML literal. So now what I can do is, instead of browsing it, I can create a new X document to surround the body, and I can save that as report.xls. And I can run this, and now I've generated an XML format of Excel. Now, because of the web, let me switch over and show you what the result of that looks like. So here was the sample, and here's what the result is. It's my query in Excel. And all I had to do was cut and paste. So just to flesh it out just a tiny bit more, it's a very simple concept. An XML document, here I've got an example one, is really just shorthand for the corresponding X-link calls. So here's the code that you would have to write if you wanted to create this thing. You'd have to remember X elements, X attributes. And of course, if you're typing in this stuff by hand, okay. But obviously, like in the Excel case, to type in all of the X-link instantiation APIs to produce that result would have taken me days. You guys would all have been home before I was done. So it's a very simple way to work with XML data in your application by making it a first-class concept. So today we've been talking about a set of features that we're targeting for Visual Basic 9.0, the next version beyond 2005. And no, that's not a typo. I've gotten some questions about what's this 9 thing. Because if you think about it, VB6, then VB7, 8, and 9, 2005 is version 8. What we've got then is a set of very powerful features that make working with data in any form, XML, SQL, objects, early bound, late bound, whatever form your data takes, you can work with it very naturally and very easily in Visual Basic. Now, the thing I want to emphasize is I talked about all these things, and we're running almost exactly on time. I've taken an hour to do this. But this isn't everything. If I had had 2 hours, 3 hours, we probably could have talked about a bunch of other things that we're considering, things that we're working on, things we're investigating, another set of features that augment what you've seen today. I can't talk about them today, but we're going to have more information on the web for them as time goes on. So really take a look out for them, because we want your feedback. Part of the reason why we're talking about this so early is we want to get your opinions on these things. What do you find useful? What more do you want? Because the truth is, even these additional things, these aren't the final list either. We've got plenty of time to work on this. And so just as we're going to be refining these ideas, your feedback is going to help us determine what is important and what new ideas we should be pursuing as well. So there's a lot of exciting things going on. Here's some information about how to stay involved. So now there's a bunch of stuff here about some of the sessions you can go to. There are a number of really interesting sessions on some of the link APIs that are going to be this afternoon and tomorrow. I've listed some of them up here. We've got some interesting sessions on dynamic programming, so the loosely typed ideas that are coming up. We've got a great set of panels on a Friday. And we're also going to be in the Track Lounge all the rest of the week, and we'll also be at the Ask the Experts tonight. So I listed up here the site where you can go to get information about future stuff, about everything you've seen here today, about some of the things that I mentioned on the last slide that I really didn't have time to talk about today. You can also get some preview bits. Almost a lot of the things that you saw today are there now. Some of the features I was writing last week, so they will be out on the web and maybe, hopefully very soon. And you can also increase my traffic at my weblog. I will be talking about these things here from a personal perspective. So that's that's it for today. Now what I'm going to do, actually, before I take questions and answers, I did want to announce one other thing. In addition to being a tech lead at for Visual Basic, in addition to writing a weblog, I've also written a book, and I have a copy here, Visual Basic.NET Programming Language. And Addison Wesley has been nice enough to donate about 6 copies for me to raffle off as a part of the talk today. So what I did was, at the exit back there, I put a very beautifully made, homemade box that has, I think, scrawled on it, raffle. And if you just drop your name in, or a business card or whatever, what I'm going to do is, after the session, I'm just going to pick 6 names out of the hat. I'll post them up on my weblog saying who won. And then if you come tonight to Ask the Experts, if you win, I'll give you a signed copy of the book. And then I will throw away it all. I'm not collecting this information for any nefarious purposes. So just so I don't get in trouble with anybody here, I'm going to have legal calling me up here. It's purely for that. So I really appreciate you taking the time to come and talk to me, listen to me talk about Visual Basic. And if you have any questions, we've got about 15 minutes now to do some Q&A, and I'd be happy to answer any questions you might have. Thanks. Sure. There are mics down here, and you just come down and line up. So if you want to start.
Yeah, when you say Visual Basic right now is native XML, yeah, are they change the behavior of to-string method so that all the to-string output in XML?
No. So you're asking. Sorry, if we could keep it quiet for the Q&A, please. Thank you. So I'm sorry, your question was?
And my question was, in to-string method, it automatically output just a string, right? But
Right.
when you talk about right now, Visual Basic is going to be all native XML. Is
Right.
that going to be change this behavior across the block?
No, we won't change existing behavior of like toString or that sort of thing. It's mostly just new behavior. So like if you call toString on, say, the XML objects, it'll just convert it to XML strings, but existing APIs will remain the same. I hope that answers your question. And we'll sort of go back and forth.
I have a question about link,
Sure.
D-Link and X-Link. How much of that is going to be delivered as sort of an add-on after the fact, and how much is this a part of like the 3.0? I'm really unclear on that part of this.
You mean in terms of the 3.0, you mean like sort of the next versions of the languages?
That's right.
Yes. So the Link project comes as a whole. So everything that we talked about today, and then the C# as well, and then the Link, all of that will be together. So when you get the query capabilities, you will also get D-Link and X-Link as well.
But is that something that's scheduled for after Visual Studio release? Or?
Yeah, actually, well, after Visual Studio 2005. But it will be part of a Visual Studio release. The Visual Studio release past the current one.
Will it be sort of downloadable, or just the link?
I don't know, actually. It's a good open question. We will have, like we've been doing now, we will have previews that will be downloadable. The exact final form hasn't been decided.
Okay, thanks.
Yeah. Yeah? Right, yeah, exactly. If you look at the preview bits here, if you go there, there'll be pointers where you can get the preview stuff for Visual Basic, and also there are pointers for C# and X-Link and D-Link and that sort of stuff too. So, oh, you know, and I forgot. Darn it. Please do fill out session evaluations too. Well, I didn't catch people, but it is very helpful for me as a speaker. So I want to encourage you, before I take the next question, do fill out the online evaluations. So thank you. So we'll go back.
Hi, I'm also a language designer. Work for the Bull programming language.
Oh, right, yeah,
we
yeah.
met before, right?
Yeah.
And Anders said in his talk yesterday that one concern they had was that languages live longer than technologies.
Right.
And now you got all this technology, this XML thing inside Visual Basic.
Sure.
So have you considered that XML might actually be a hassle for Visual Basic, actually something that...
Right. I mean, definitely we're aware of that, sort of the risks involved in integrating any sort of feature in the language itself. And I think there's sort of two answers I have to that. The first is, of course, that we're pretty sure XML is going to stick around. but that aside, actually, yeah, we're very careful that what we're doing is additive, and the form may change a little bit as we kind of sort of work with it and get feedback as well, because we don't want to have it be where, if next year XML 9.0 or 2.0 comes out and totally replaces XML, then now you have this completely dead technology cluttering up things. So we do definitely want to take a very additive approach to it. So.
All this stuff is really cool, and I think it'll make us really more productive in a lot of ways. But what are the performance implications of some of these things? I mean, I know what it takes to do some of this stuff.
Right.
And if it's doing the stuff on the fly, I mean, can we still do the things that we normally do for performance reasons, or is this going to compile the stuff in a way that we result in the same code base anyway? You see what I'm saying? If I use these functions,
right,
do I get the same missile code in the end that I would if I used, X documents and done all that stuff?
Right, exactly. So for all of these things, we compile down to the APIs that you would normally be using anyway. So we're not doing special magic that it's involved. And certainly, like for a lot of the late binding things, you know, there are performance implications to late binding, and it's really a question of whether you want to use it, what you need to be doing. You can always, it's sort of like a slider bar if you think about it. It's like at one end, you can be completely dynamic, and you can always slide it back towards being more typed if there are some performance things that come up. I mean, late binding isn't actually that slow, but you know, there are always things that come up. And similarly with the queries, you know, performance is something that is very important with this, and it's something we're thinking a lot about, and ensuring that all of this stuff performs very, very well. So.
Are we ever going to get multiple inheritance in VB?
Well, that's a good question. Multiple inheritance is ultimately would have to be a platform feature. So the CLR, the .NET runtime, doesn't support multiple inheritance. It's certainly something that comes in as requests to all the languages and to the platform itself, and it's something that we consider. I'd say it's unlikely in the immediate future that it would be added to the platform. So.
I have two questions about my.
Sure. I will do my best to answer them.
My is an extension or not?
An extension of?
Extension or expand?
Yeah,
or
right.
Not?
I'm sorry, I didn't.
Next version. At next version.
At next?
My has computer and application user and.
Oh, right. Oh, will it be extended in the next?
Yes.
In the next
or
version?
Not?
Yeah, I mean, that's something that we're definitely looking at. Because we did a lot of the most common things that people will want to use. But obviously, that list grows over time. And so I think we will be probably adding things to my over time. And if you have any suggestions for things you'd like to see there, we definitely want to hear them. So.
Okay. And two questions.
Sure.
Do you like my?
Do I like my? Oh, yeah, definitely. Definitely. I didn't really get it. Unfortunately, I was so focused on the new stuff, I didn't get a chance to use it. But actually, in some of the utility code behind there, I used it in several places to load files and to do other stuff. I think it's great.
Thank you.
So, thanks.
Paul. Hi,
Yeah.
Paul. One question I have is, so far we've seen a lot of the SQL syntax being put in here for doing queries.
Yeah.
Are you going to do any things with data manipulation, like updating things, inserting things into collections, or inserting things into tables?
Right. I mean, that's definitely something that it's like on our list sort of once we get this solidified a bit to take a look at, because it's obviously an extremely useful. Once you can select, it'd be great to bulk, you know, take a collection and set all of the prices to be twice the amount and just write it in a single statement. So, yeah, I mean, that's sort of the, if you go back to the more to come, I think that for us, that's one of the things that goes in the more to come. So.
I'm interested in how you actually implement LINQ. The C# talks about LINQ, you know, they talked about Lambda expressions and how it's code as data, and that's how D-Link uses it to produce SQL. But it looks like you don't have Lambda expressions. So there's no code as data.
Well, no, actually what we did was, because like I said, kind of if you go back here actually even too, you'll sort of see Lambdas up there. Because I didn't really have time to go into every feature to get to some of the other things. Lambdas are definitely something that we're looking at as syntax for, maybe as local functions, maybe a completely inline syntax. Because definitely we have to support them for LINQ, and for D-Link especially, to be able to translate an expression into a set of objects is going to be a requirement to work with that. So we will have some support for that. I just didn't get a chance to talk about it today. Definitely.
So the syntax you showed that the compiler generates actually used delegates with address of some generated function.
Right, and that's the fully expanded form. Like what you would have seen is you could have seen, instead of the delegates, you would have just seen a Lambda function. But what you saw in the example was a fully expanded Lambda function, if that makes sense. So essentially, if you had compiled C# code, the equivalent query, you would have seen something much the same once you had fully expanded out all the features. So.
Unless it was D-Link, which doesn't use.
Right, exactly. I didn't show any D-Link today, but if there had been D-Link, it would have expanded out into creating expression objects rather than delegates. Definitely.
Hello. Hey, as a follow-on to this gentleman's question, would there be any way to extend the select statements and the other SQL statements into other data sources that aren't directly mapped, third-party databases, et cetera?
Yeah, I mean, so I sort of touched on that a little bit in that because it's built on top of the link APIs, which are very open, it will be very possible to plug in new data providers, both underneath, say, something like D-Link, which is built onto the ADO.NET provider model, or directly. So if you want to directly process the queries, and if you go look, if you look at if you go to the website and look at some of the documents we have there, they'll talk about the standard query operators and kind of how to do that. So it's totally something we want to support.
Excellent. Thank you.
Yeah. All right. Nobody's over there, so.
Do you have any idea if the D-Link is going to work at all with the jet engine?
I have no idea, actually.
Okay.
Although I have to admit, it's near and dear to my heart because before Visual Basic, I worked on Access. So, but I don't know.
Okay, thanks.
Sorry. All right. Any other questions?
Just the one you can't answer. When?
As soon as possible. Believe me, this has been a lot of fun to work on, and I'd love to get this to people as soon as humanly possible. Well, great. Thanks for coming. I really enjoyed it.